In the situations where a database is involved and we have to be concerned about transactions, that is making sure that the data that we store and retrieve is consistent with respect to the overall database, we have to deal with transaction processing, and in particular with what are called the ACID properties. The primary concern is reliable database access, particularly when there are multiple readers and writers. That is, parts of the application reading from the database and other parts writing into the database, particularly in addressing a specific record. Imagine that you were in a situation, maybe you were doing airline reservations or something like that, and you need to understand the information in the database, but you also may want to update it if you're making that reservation. Okay? So you have to read it, examine it, change it, and then write it back. What happens if another application changes the record after you've read it, but before your changed version has been written back? So we'd like to have database transactions that satisfy the ACID properties. And ACID is an acronym. The A stands for atomic. That means that your transaction, these 4 steps, reading, examining, changing, and written, are all treated by the system as if they were one step with no intermediate activities going on. The C stands for consistency, preserving, in the sense of database integrity. Okay, that is, if the database satisfied all its integrity constraints before your transaction, it will also satisfy them after your transaction. Third, the letter I stands for isolated. Okay, and what that means is that other transactions can't see into any intermediate states in the processing of your particular transaction. And finally, D stands for durable, and that means that once your transaction commits, then it's persistent. That means it is a permanent record that the system is aware of.